Welcome back. This video is to follow up the previous video of multiplying fractions. If you can multiply fractions, then dividing fractions should not be much of an issue. Now, when you see two fractions and you see your division sign between them, what you're going to do first as your first step is you are going to change this into something you already know how to do, which is multiply. So to multiply fractions, what you do, to divide fractions, what you do is you multiply by the reciprocal of the second fraction. Okay, so I'm just going to write that down for you real quick. You're going to change this and you're going to multiply by the reciprocal of the second fraction. Now, that word reciprocal, if you do not know what the reciprocal is, I will show you in just a minute. Okay, reciprocal just means to flip the fraction over. So I'm going to change this problem. The 5/8 is going to stay 5/8, so 5/8. I'm going to change the division sign to a multiplication sign. And now instead of 3/4, I'm going to put the 4 in the numerator and the 3 in the denominator. I'm now ready to multiply, and if you remember from the previous video, I like to reduce first because I like to have the smallest numbers possible. So I notice that 4 is going to go into 4 one time, 4 goes into 8 two times, and there's nothing else to reduce, so here goes. In the numerator, I've got 5 times 1, which is 5. In the denominator, I have 2 times 3, which is 6. That problem is done. The next problem, same sort of thing. I just put this on here to remind us of what to do when I have signed numbers. And so we are dividing again. So step one, before I worry about signs, before I worry about reducing, I am going to multiply by the reciprocal. I just want to make a little note if you're taking any notes. Do not reduce a division problem. I know it's tempting. You see that 12 and 21 share a common factor. You cannot reduce until it's multiplication. So here we go. Negative 16/21, my first fraction is not going to change at all. Then I change the division to multiplication. And then I change negative 12/11 to negative 11/12. Notice the reciprocal. The sign stays the same. We do not change that. So, as I mentioned, I'm now going to reduce. There's only a little bit to reduce here. 12 and 16 share a factor. 4 goes into 16 4 times. 4 goes into 12 3 times. And then there's nothing else to reduce. So here we go, our final answer. I have a negative times a negative. That's going to be a positive result. I don't write a plus sign. I'm just going to assume. And then I have 4 times 11 is 44. And then 21 times 3 is 63. All right, I'm going to fast forward to the next slide. I've got 3 examples for you. Why don't you pause the video and give your best attempt at these 3 problems, and I'll see you in a minute. Welcome back. So here we go. Check your work with mine. I'm going to run through these problems. If you have any questions, you can always contact me through the math community, or you can email me at my Polk State address. It's I don't know what just happened there. It's sjperkins@polk.edu. I'm happy to help you out. Just ask whatever questions you need to. So first thing I'm going to do with this problem is I've got 1/5 times 7/4. Nothing reduces, so when I multiply my numerators, I get 7. I multiply my denominators, I get 20. Problem done. The second problem, again, do not reduce. Do not reduce until it is a multiplication problem. So I'm going to make this negative 9/45. All right, here we go. 5 goes into 20 4 times. 5 goes into 45 9 times. And you notice I can cancel that 9, the 9 in the top, with either the 9 in the bottom or 9 goes into 27. Pick one. Okay, you can't cancel with all that. So what I'm going to do is I'm going to cancel 9. 9 goes into 9 once. 9 goes into 27 3 times. I have no real reason for picking that other than I wanted to use the other fraction. You get the same answer either way. So I have a positive fraction times a negative. That makes my final answer negative. I've got a 4 times a 1. That's 4. And then I've got a 3 times a 9, which is going to be 27. Last one, the reason I put this problem on here is what to do when you have a whole number involved in your fractions. And what I always like to do, whether I'm multiplying or dividing or adding or subtracting, is write that whole number over 1. That way I know that it has a numerator and I know it has a denominator. And so this problem becomes 18 over 25, and now the reciprocal of the whole number 6 becomes 1 over 6. Going to reduce, 6 goes into 6 one time, 6 goes into 18 3 times, and so when I multiply my numerators, I have 3 times 1 or 3, and then my denominators, 25 times 1 is 25. And that is it for dividing fractions. Practice, 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 so you can be really good at this, and I will have more soon.